Hi, I'm Ms. Hall, and this is Lesson 87, Normal Distribution Empirical Rule. We'll begin with distributions, and we'll learn about normal distribution by comparing it to uniform distribution. For normal distribution, there is a single most likely value. The graph of data that is normally distributed will be bell-shaped, with the mean in the middle. In an example of data that we expect to be normally distributed is the blood pressure of 1,000 randomly selected males. It's probably a common blood pressure that they have, but there's going to be some variation, and maybe there'll be some extremes, but not a lot. So we expect that to be a bell-shaped curve or normally distributed. Another type of distribution is uniform distribution. And this is where every allowable value is equally likely. One example of displaying this data is a histogram, where each bar is the same height. An example of data we expect to be normally distributed is the number that comes up on the roll of a fair die. If there's an equal chance of any of the numbers coming up, we expect uniform distribution. Now let's talk about the empirical rule. The empirical rule states that for a normal distribution, nearly all of the data will fall within 3 standard deviations of the mean. The empirical rule can be broken down into 3 parts. 68% of the data falls within the first standard deviation of the mean. 95% fall within 2 standard deviations, and 99.7% fall within 3 standard deviations. The rule is also called the 68, 95, 99.7 rule, or the 3 sigma rule. Okay, so let's talk about the area under a normal curve. A normal distribution with mean mu, and standard deviation sigma have these properties. The total area under the related normal curve is 1. Right? 100% of the data is going to fall under the curve. About 68% of the area lies within 1 standard deviation of the mean. About 95% of the area lies within 2 standard deviations of the mean. And about 99.7% of the area lies within 3 standard deviations of the mean. This is exactly the empirical rule. So you can see they've done 2 graphs. Same graph, but they labeled it differently. So you have the mean, and then within 1 standard deviation of the mean is 68% of the data. You could also show that you have the mean, and on either side of the mean, 1 standard deviation above the mean is 34% of the data. 1 standard deviation below the mean is 34% of the data. And you could keep going. You could say 2 standard deviations above the mean. You could add those and you would get 47.5% of the data is 2 standard deviations above the mean, or 2 standard deviations below the mean is 47.5. So you can see these 3 numbers, 68, 95, and 99.7 are easier to memorize. And then you just have to know that 68% is 1 standard deviation above and below the mean. So if you're just going 1 above or 1 below, you have to cut that 68% in half. Example 1, a machine is used to put bolts into boxes. It does so such that the actual number of bolts in a box is normally distributed with a mean of 106 and a standard deviation of 2. Approximately what percent of the data is between, now we have all these ranges. I'm going to begin by filling in this graph. So the mean is 106 bolts. The standard deviation of 2 means that 1 standard deviation above the mean is 108 bolts. 2 standard deviations is 110, and 3 is 112. See, I keep adding the standard deviation of 2. And then I'll go below the mean. I'll subtract 2 and get 104 volts is 1 standard deviation below. 102 is 2 standard deviations below, and 100 is 3 standard deviations below. Now, while these numbers are in my head, I'm also going to write out the empirical rule. We have 68% of the data lies within 1 standard deviation, 95 lies within 2, and 99.7 lies within 3. Okay, now let me start to answer these questions. Approximately what percent of the data is between 0 to 106 volts? Well, 0 to 106, that's the minimum value of volts that could be in a box. You can't go lower than that, to 106, which is the mean. And the mean is exactly at halfway of a normally distributed data set. So 50% of the data lies between 0 and 106 volts. Now, between 100 and 112 volts, well, I've actually labeled that on this graph. That is 3 standard deviations with it, but it lies within 3 standard deviations of the mean. So this is 99.7%. 102 to 110 is 95%. 104 to 108 is 68%. And 106 to 108, well, that's 1 standard deviation above. And so it's half of 68%, which is 34%. There's one other thing I wanted you to be able to say, and that is, for example, that 104 is some amount of standard deviations below the mean, and 110 is blank standard deviations above the mean. So this is vocabulary you're going to see on our worksheets. I want you to be comfortable with it. So 104 is 1 standard deviation, right? This is 1 standard deviation below the mean. And 110 is 2 standard deviations above the mean.